Good afternoon, everybody. Thanks for joining us and welcome to this session. I'll start with a small introduction and then I'll go through the presentation, followed by a small demo for the apps. And later on, I'd like to take any questions from the audience, if there are any. Starting with the introduction, my name is Avichal Sharma. I'm working as a technical architect, mobile developments at Accenture. I started my career as a C# and Microsoft developer. Later on, I moved to Objective-C with the introduction of the first iPad, as I remember. And for the last couple of years, I've been working on Xamarin platform, and we are developing cross-platform mobile applications for different clients. Accenture is a big company. It has offices like all over the world. And our Accenture office is located right there on the map. We're coming from far away. It was like a 13 hours, 55 minutes flight from here. We're coming from a city called Istanbul. Istanbul is a beautiful city of Turkey. It's the financial capital of the country, famous for a lot of different things, but most of all, it's famous for the fact that it connects the two continents, Asia and Europe. And as you can see, this is the famous Bosphorus Bridge that does the work for us. It's a really good bridge. I mean, as long as there is no traffic, it's really nice. Moving back to the topic for the session today. Today, I'm going to talk about the mobile technologies for the emerging medical devices. And to start with, it's like for the last 1 year or so, our company has been working for the development of a cross-platform mobile application solution for a special category of medical wearable devices. Well, these devices, whenever anybody talks about the wearable devices, the first thing that comes in everybody's mind is the Google Glasses or something like that. But these wearable devices are not like that. Sorry to disappoint you for that. But believe me, these devices, they are being used by many more people when compared to any of those gadgets or devices. So what are these called? They're called hearing instruments. They are being used by the people who experience any kind of hearing loss. How do you use them? You just plug them into your ears, and they are configured with different kind of programs to help you hear better. Technically speaking, they are miniature amplification systems which are specially designed to increase the volume level of the sounds that you want to hear. So, do we manufacture these devices at Accenture? No, we do not. We have nothing to do with manufacturing these devices at Accenture. But our client does. And who is our client? The client, I think you must recognize this name. It's Siemens. And precisely, it's Siemens Audiology. So Siemens Audiology is a company which has been manufacturing these devices for like decades. And they are one of the leaders in providing hearing aid solutions to the whole world. They're kind of trendsetters in this industry. So we have been working with them for years, and this particular apps that we created, this is specially made for Siemens. So requirements. It's like we are working with Siemens for 6 years. We have done a lot of work for them. We have created the commerce applications, some Windows applications, the WPF stuff with them. And the last year, they came to us with a vision for creating a smart app solution for their next generation of hearing aids that they were manufacturing at that point of time. So he came to us with this vision and some set of requirements, the initial requirements that we got from them. So the requirements were quite straightforward. They wanted us to create a remote control app. An app that could control the hearing instruments, especially the instrument that they were creating at that point of time, the next generation ones. And of course, the hearing instruments are not the only hardware that is related to this whole hearing aid solution. There are different kind of accessories with that. So they wanted our application to work with all of these devices seamlessly. The next thing was they wanted the app to work on multiple mobiles. For the beginning, they wanted it for the iOS and Android devices. Well and good. So the next thing was the app should be able to comply to the Bluetooth communication protocol, because there are a lot of devices that they were manufacturing which support the Bluetooth communication, and our app was supposed to talk to them whenever it was required. This one was interesting. They wanted the app to handle all kind of audio streaming. So with audio streaming, what I mean is if you get a phone call, you should be able to hear the audio via your hearing instruments. Suppose if you want to watch television, you want the audio to output to your hearing instruments. So stuff like that. If you want to listen to a song from your iPod, you should be able to stream any kind of audio directly to your hearing instruments. And lastly, the choice of everybody, it's like it should be maintainable. Since Siemens is creating these instruments all the time, they are increasing the functionality which is inside. So they wanted the application should be able to support the new upcoming feature and maybe the new upcoming devices altogether. And that's why they wanted the code to be something like maintainable. So they wanted us to create kind of a business layer at one place so that they could just go ahead and put their new devices, new regulations at one place, and no need to care about the UIs and stuff like that. So the requirements were quite clear, but the first question that came in our mind that's really good. It sounds like a very good application, but at the same time, it sounds like we have to talk to a lot of devices of different types, different categories. So what are these devices that we need to actually talk to? So there are a lot of devices. Actually, if I start talking here, the time is not enough for that. But mainly, the app has to work with these two devices. Of course, the hearing instruments. But the hearing instruments, they are of different sizes, different shapes. They support different kind of functionalities. And there are the instruments which are configured with different programs. So if you go to your hearing professionals, if you experience any kind of hearing loss, you go to your doctor, he'll configure the specific program, especially that are meant for you. So this was a one device that our app supposed to work with seamlessly without any problems. The second device was the easyTek Bluetooth device. Now this device is a new device. It's not launched in the market as of now. The real launch date is going to be 7 days later. So it's a neck wear. How you wear it, it hangs around your neck. You wear it just like your badges. And it supports all kind of Bluetooth connectivity and supports some advanced features for the audio streaming. So the features that I talked about right now, like streaming your television and all, if you want to do that, you need this device. So these are the two devices that were the main guys we need to talk to while creating the app. So what are the different kind of communication protocols that we really implemented in order to achieve this kind of communication? So the first one was the Acoustic Commands communication. So Acoustic Commands mode is, it's like your app. It sends very high frequency, it's ultra high frequency tones, and it generates them, it sends them, and these tones are being captured by the microphone of your hearing instruments, and they understand, they decode the message in between that, and immediately they react to these commands. So this was the first kind of communication. The good part of this kind of communication is you don't need any kind of extra intermediate device. And it works with all the Siemens instruments. So, I mean, just think about it. The Siemens start manufacturing the instruments. You have bought it previously. You just need to go and download the app, and you can connect it, because it does not require any kind of Bluetooth technology or something. But there are people who want advanced features as well. For example, if you cannot watch your television, you cannot listen your songs using your hearing instruments, it's not enough maybe for some of the people. So for that, there was a second kind of communication, that is the Bluetooth mode communication. In that case, the application does not talk to the hearing instruments directly. Instead, there is a device which stands in between the instruments and your application, and which is the easyTek Bluetooth device, the neck wear. So what happens, your app, whenever you press any button, you want to change the program, you want to put the volume up or down, you send the command, a Bluetooth command, it goes to your easyTek Bluetooth device, which in turn forwards it to the hearing instruments, and this way the whole communication happens. It's a two-way communication, so the app can send commands to the instruments, and it can receive the commands from the instruments. So if I change a program here, my instruments know about that. And if you change the program from the instruments, the app knows about it. So every time they are synchronized. So it was not easy for us, because this is not an app that you get to develop for every next client, because this is a very serious app. This app, we had to deal with the different devices. We had to comply to different kind of communication protocols, and we had to go through a lot of certification process. And I'm not talking about the Apple and the Google Play certifications. It's like you have to go to the health ministries, you have to get the FDA certifications and stuff like that. So it was a very serious app for us. Anyways, after 1 year of hard work or something, we came up with a solution, and it looks something like this. So we have created a smart remote control for the next generation of hearing instruments, and it's available for the iOS and Android devices. It looks something like this. So now you don't need to go behind your ears and to change the program. You don't need to go behind your ears to change the volume. Or the biggest reason that there was a requirement for such kind of app is the instruments, they are very small. And nowadays they are so tiny, they go inside your ears. So it's practically impossible to go inside your ear and change the program. So you literally need a kind of app or some kind of remote control that could do the justice, and you can completely control the instruments. So what can you do? You can do a lot of stuff with it. You can change your programs. The right screen that you can see on Android, it's called the narrow focus. So you can actually focus on a specific direction. For example, if you're listening to me right now, you can focus your direction towards me, and you can ignore the sounds which are coming from your left, right, and your back. So this is something which is not available in the market as of now. And it's still not available because the official launch of the apps and the devices is going to happen after 7 days. So, well, I confused you guys too much with a lot of devices and a lot of different kind of protocols. So I would like to go through that how this all makes sense. So how this all works together. So this is how it works. You have your hearing aids. Your hearing aids, you plug them into your ears, and they are configured with different kind of programs. And if you have a little bit more money with you, you can buy this smart easyTek Bluetooth device. So you just wear it. It hangs around your neck. And then you just need to go to the App Store or Google Play and download this app. Now, the moment you start your app, it will detect that you have an easyTek Bluetooth device with you. It's going to pair with the device, and it will start reading all the information. So right now, what you see, the UI over there, the app starts with a 0 UI. So we read all the information from the hearing instruments, and then we create an intuitive and simple UI, present it to the user so that he could understand what is happening and he could control that whole thing. But for example, I bought this device. I'm wearing it, but I cannot carry it with me all the time. For example, I want to go outside. I want to go for a walk. I don't want to carry this device with me, but I want to use my hearing instruments. I want to control them still. In that scenario, what to do? This is what happens. This application supports a smart fallback mode. So if you do not want to carry your device, you just switch it off, leave it behind. The application will automatically fall back to the acoustic mode and will start talking to your devices using these acoustic tones, which are very ultra high frequency tones. They are not disturbing to human ears. If I use my application here right now, which I'll do in the demo, you won't be able to hear what is happening. So this way, ultimately, this app is smart enough to know when to talk on Bluetooth and when to just broadcast the sound messages, the sound waves in the air so that the right device will capture it. So in the process, we have created, in fact, 3 different apps. We call it the suite of apps. And they're called the touch control app, which is the acoustic-only app. So you don't find any kind of Bluetooth communication in this first app. The second is the easyTek app. And of course, you need easyTek Bluetooth device if you want to use that app. If you don't want to buy that device, that app is of no use for you because you must have to have that device. The third app is called Binex Demo. It's an enterprise-only app. It is not made for the consumers all over the world. This app is basically the marketing app for the hearing professionals, so they could show off the features, the marketing features to the patients. And so to start with the touch control app. Well, the touch control app sounds simpler when compared to the Bluetooth app, the easyTek app. But this app has something called, it can reach to a lot of customers because not every customer will be able to buy the Bluetooth device because they are really expensive. But if you have your hearing aids with you and you bought them from Siemens, you can just download one app, free app, and you're good to go. You don't need to go and change your programs, control them using your hearing aids. So I just want to show you a small video about the touch control app and what it can do for you.
This is Lisa. She is discussing hearing instruments with her hearing care professional. Discretion is right at the top of her wish list. She doesn't want people to notice she has a hearing loss or see that she is wearing hearing instruments. But also, she wants to control how she hears. The hearing care professional not only has a suitable hearing instrument ready for her, she has just the right thing for adjusting it discreetly. The Siemens Touch Control app. Lisa is curious. What's that then? The Touch Control app works on most smartphones and can be used to adjust the various functions on a hearing instrument easily and without the need for any additional hardware. To anyone else, it just looks like Lisa is checking her phone. Great! But how exactly does it work? With the help of the app, the smartphone sends out special ultra-high frequency tones. These are picked up by the microphone in the hearing instrument and it reacts straight away. That's impressive.
Wow.
And it's really easy to use. This means that Lisa can adjust the volume, treble, and bass easily and switch programs to have greater control of how she hears. The Touch Control app works with the latest generation of Siemens hearing instruments and with a smartphone, iPhone, or Android. Lisa is happy. Now she has a great solution to meet her needs. Ultra-discreet hearing instruments with an ultra-discreet remote control. The Touch Control app from Siemens. Life sounds brilliant.
So this was the Touch Control app from Siemens, and it's on the App Store and the Google Play right now. You can install it any point of time. But the official launch for these apps and the devices is going to happen like 7 days later, as I told you. So the second app in the sequence the much more advanced app, which uses the Bluetooth protocol, is called easyTek app. So we also call it the extended remote control because it actually extends the features of the touch control app. So in this kind of app, you have a two-way communication. So you can see the moment you open the app, it just goes to the Bluetooth device. It tells the device, please give me all the information about the hearing instruments. It creates the UI for you. And it is a two-way communication. It can connect to different kind of devices. You can see a device down there. I'm sure nobody recognized that kind of device, if anybody is there. Yeah, these are called transmitters. So these are the devices which are used, for example, if you want to connect to your television that does not support Bluetooth. So what you do, you can connect your television with a line-in cable using this device, and that way you can actually stream the audio from a non-Bluetooth supportable devices to your hearing instruments. So this is one of the category. There are lots of different devices that we support inside the applications, we connect to them. So if you want to do audio streaming capabilities, I mentioned it before also, you need to go for this kind of app. The third in the picture is the Binex demo app. Of course, it's only for the marketing stuff. And you can see there is a different kind of situations, the car and the noisy situations. It's basically meant to show to the patients that what are the different offerings available from Siemens in the upcoming year for them. So just quickly, I'll go through some of the screens of the apps. Maybe it'll be of interest to some people. So you have a dashboard which tells you what kind of program is currently selected, what kind of controls are available for that program. You can just put the volume up. You can have this tinnitus noiser. Tinnitus, for the people who don't know, it's a kind of that irritating sound that generates inside your ear. And when you pass 35, I'm still on 35, so I'm going to hear it soon. So in order to adjust that kind of thing, this tinnitus noiser is something that helps you. Then you have a program selection and the audio source selection screens where you can just go and select the kind of program you want to select. The third screen is the narrow focus I talked about. It is a very interesting feature. We have got very nice feedback from the customers right here from US as well. This is a brand new feature. It's not available in the market as of now. So in this way, you can actually focus on a specific direction. And not just front, left, right, and back. You can actually zoom it to adjust it to exact level you want to listen from. And then there are a lot of settings, and in the settings, there are a lot of catchy stuff. It gives you the information about the battery lives of your instruments, whether it's the hearing instruments or your Bluetooth device. There is a setup functionality. You can go through setup and repair to a different device altogether. Here's the Android counterpart for this. So the last screen is of interest. I talked about the transmitter. So if you want to connect your transmitter to your app, it's very simple. You just need to scan the barcode. It's on top of the transmitters, and you're good to go. So that was about the applications from the consumer's point of view. Now let's dive into the Xamarin workspace, how we use Xamarin, and how Xamarin helped us to actually create this kind of app. So this slide is a very basic slide, I'm sure. Everybody can understand. It's a core project. This is the reason why we all come to Xamarin. So we also had a core project where we put all our business rules, and then we have a iOS and Android projects separate, just to handle all the stuff which is device specific. So what we were having in the core project was we have like 60 plus Bluetooth commands that we are exchanging between devices. So, and these commands, they're not of same kind. They are of different category. They are of different byte length. They don't look same when you look them. I mean, I remember there are like 10 different kind of command structures that we needed to create. So all these command structures we put in the core layer. And then there was a command parser, which is smart enough to, you just give him any kind of command, it parses and gives you the result back. So all of the acoustic tone generation algorithms, all the acoustic stuff, we just put it there. And this is not simple. We have used, I should say, very complex algorithms to create these sounds. And these sounds are different. They encapsulate commands inside them. So, and it's not anybody can understand them. So if you want to send a command using acoustic tone, the device has to first pair with the device. So that also happens using the sound waves. So it's a very complicated stuff that we have done, and thankfully we are able to achieve it. We had a choice to go. It's not a data-intensive application. You all can guess. So, but still, we decided to go with SQLite. The reason we could have gone with the NS user defaults for iOS. We could have gone for shared preferences for Android. But then it doesn't make sense because our whole idea was to use just one layer for everything. So, and SQLite is a very lightweight database. So we just put everything there, whether your configurations, your user preferences, everything there. Then there was a branding. Now branding has to do with the color schemes, the fonts. The Siemens applications, they deal with different fonts, different kind of color schemes. And also, there's something called hardware authentication. So, for example, Siemens sell these devices with different kind of price points. So one functionality which is available for you might not be available for some other guy because he did not pay as much as you paid for it. So when you open the app, we actually does this authentication. We actually check the price points, and we give you the functionalities which you actually bought by giving the money. So this all stuff is also in the core project. Then there's always device-specific things. Of course, we cannot put them in the core layer, but we put the rules in the core layer. So all the interface definitions are there, and all the iOS and Android devices, they are responsible to implement these protocols at their side. For the iOS project, we use the external framework, external accessory framework, sorry, because this easyTek Bluetooth device is also having a MFI chip inside it. It is made for iPhone. And for that, we went through the external accessory framework. We implemented the complete communication using that. Then we had the general storyboards and the zip files. We have done a couple of native bindings as well. One of them was the branding, because branding is the library given to us from Siemens. And it was Objective-C and Android library. So we had a choice whether we go ahead and, completely write from zero, write a C# code for it. We tried the binding, and it worked really well. I mean, it was not that hectic to bind your libraries for Xamarin. The other was a Omniture library. I don't know if you have heard of that. It is one of the library for analytics work, if you want to capture the analytics, the real-time usage of your apps. So we have used that. It also comes as an Objective-C and Android version, so we binded it. We have used the base view control model, of course, because of the event handling. There's a lot of events firing all over the places, and we want to capture these events at every place on the UI. So this was a normal model that we followed. For iOS, local notifications to let any UI screen know about like what is happening. If there is a message coming from the Bluetooth device, we just broadcast that message using the local notifications, and the UI which is there on the screen right now, it understands and does the update. And for the people who work on the background processes a lot, they must be knowing that this async and await are kind of a lifesaver for that. So whenever we need to do the kind of background process, we use async await. We just go out of the UI thread, go back, do our work. Once we are done, we just need to call the invoke on main thread method, and we are good to go. We can redraw our UI accordingly. So for Android, it was a different implementation for Bluetooth because we use the core Bluetooth for it. For Android, there's a special thing which is not available on Apple as of now, but I'm sure it'll be there soon. That's widgets, the smaller version of the app. So you can just put the widget on your main dashboard, and it gives you a most used features, so you don't need to open the app and go there for these things. The same native bindings available for Android version as well. So we have done the UI layouts and styles and resources, the media stream for playing the tones. And the same thing, async await, was applicable here as well. But if you want to come back to the UI thread, you just call the run on UI thread method, which is the same like the iOS version. Now, I'd like to talk a little bit about the continuous integration stuff that we have done for this particular project. So we actually had two teams. We had Android team, we had iOS team, and we had kind of senior developers who were working on the core layer. So in the core layer, we have all the stuff that I mentioned before. So whenever we needed to take a kind of build, whether it's automated build or the manual build, we had used Jenkins build server for that. So you just whatever kind of build you want to take, it just checks out the latest source code for you. It does the build for you and gives you the IPA or the APK files, whatever you asked for. And just to show you, I've taken a screenshot from our build server here. You know, the biggest thing what happens with, especially with the iOS devices, is the provisioning profiles. So we have different provisioning profiles. A client was sitting in Germany, and we were developing in Turkey, and we had iterations of like 3 weeks. So at the end of every iteration, we had to give the iteration version to our client for the review. So there is a lot of stuff. There is ad hoc version whenever you want to do internal build. And then for the App Store, you need to do a different kind of version. So if you see on the screen, we have actually written a small script for this thing. You just select the brand you want to build it for. You select whether you want to go for the ad hoc version or the App Store version. You just specify what kind of provisioning number you have, what code signing key you want to use for this particular build, and press the build button. You're good to go. It creates the build for you. So it does these things both automatically and manually whenever you require. So a little bit about the code reusability, for which everybody comes to Xamarin. Well, the basic idea is that if you use Xamarin, you can share the code between the Android and the iOS versions. But if you see here the acoustic core component that we have used, it is right now it's being shared among 6 different apps. So this one project that we created, right now it's being shared by the Touch Control Android and iOS version, the easyTek app, both the versions, and the bindings demo as well. So this is one very good part. Once you create one, it's kind of a component, so you can use it in any number of apps you want to. And then there is a Bluetooth core, which is, as you can see, it's only used by the easyTek app, so it's not available for the rest of the apps. And some kind of metrics, a percentage. So how much percentage of code we were able to share. So for the touch control, we actually were able to share like 50% of the code. It's the approximate figures, but we are very close to it. For the easyTek app, we were able to share the 60% of the code. So just think about your Bluetooth app. If you're creating any kind of Bluetooth application, it's wonderful to have 60% of the code written once, so that later on if we want to write it for the Windows Phone, we don't need to do all that hard work. And for the Binex demo app, same way we were able to share like most of the code, 70% of the code was shared. So that was the theoretical part of it. And now I would like to show you a little bit of demo. I'd like to dive into the demo. Before that, let me just show you the devices that I talked about. So this is the Bluetooth device, what you wear around your neck. And right now what I'll do, these are the hearing instruments, by the way. They are a little bit big right now because I wanted to demonstrate, but they come in very small sizes. You cannot even see them. So what I'll do, I'll wear them right now. Oh, it switched. Very nice. Yeah. And here I'll wear my easyTek device. I'll just check whether they are paired. Yeah, that's it. So here you can see on the screen there are 3 apps that I mentioned. Today I'll give you a demo with the Bluetooth version because it contains everything. But I've chosen some kind of scenario because it is really difficult for me to demonstrate the full features of this app, because for that you guys need to wear them. You cannot understand. So first thing what I'll show you is the synchronization between all these devices, how they work together. So I'm going to open the easyTek app. You can see it's connecting to this easyTek device right now, and it read all the information. So right now what you see on the program is the outdoor sport is the program which is configured on my hearing instruments, and it's currently selected. So if I want, I can just go and change the program, and I can see the effect here, but of course you cannot. So what I'll do right now, I'll go other way around. We created the app to control the instruments. What I'll do right now, I'll control my app through the instruments. So what I'll do right now, first I'll go with the Bluetooth device. It has a button on top of it to change the programs. So right now I'll change the programs. You can see the app immediately understands this, synchronize it, and changes accordingly. At the same time, it has a few buttons here to change the volume as well. So if I change the volume, you can see the slider down. It's moving, it's understanding. In fact, in the real time, it happens other way around. You control everything from your app, but this is just for showing you. Now, this way you can see this easyTek device and the app, they are synchronized all the time. And now what I'll do, I'll control my app. Instead of using this device, I'll control it using my hearing instruments. As I told you, they have small buttons behind them. So the right side, as I remember, is for program change. So I'll change my program from here. You can see, right now I'm controlling my app via the hearing instruments. Now, let me just try and change the volume the same way. There you go. So this is the way right now, all these 3 things, 3 entities, they are working together. They are synchronized. They know each other. They know what everybody is talking. And the first question that everybody will think at this point of time is then, where's the need for the app? If you can control everything from here, you can press the button. Well, it's not practical. It's not practically feasible to put all the controls inside the hardware, because there are so many controls, and you have very limited number of buttons you can put here. So, and for the hearing instruments, even that is not possible because they are getting tiny day by day. With every next release, people are not very comfortable in showing off they are wearing these hearing aids and all. So nowadays the hardware is getting more and more tiny. It's not even visible. So it's practically impossible to put all the functionality in the buttons in terms of hardware. So with the narrow focus is one feature I really want to demonstrate. Although you might not be able to understand until unless you wear these devices. So this is how it works. Right now, I'm able to capture the sounds from everywhere, from all the directions. But suppose if I want to focus just on my front, right now I'm ignoring the sounds from my left, right, and back. And the same thing I can do with the other stuff. And then there is something called IntelliZoom. You must be seeing the slider down there. So this is to go even further. So if you want to really adjust the exact location, I just want to capture from here. You can be very specific. You can zoom into a specific direction that you want to listen from. So this was one of the feature which is not available in the market. I'm mentioning it again and again because we really worked very hard for this particular feature to put in. And now I would like to show you a little bit about, I told you about there are two different modes, and application is very smart that if you don't want to carry your Bluetooth device, it automatically falls back to acoustic mode, and you can still continue to control your instruments. So what I'll do, you can see right now on the screen, you have a battery levels from the devices. Now what I'll do, I'll just close my Bluetooth device, and let's see what's going to happen. So you see the application immediately understands that, hello, you don't have the device anymore. You cannot carry on with your Bluetooth stuff. You have three options. Either you try and reconnect. If you cannot do that, just go through the setup process once again. Or you can just use it as touch control. That means the acoustic communication. So what I'll do, I'll just select the touch control option. And here you go. Right now, I don't need this thing, but I'm still able to control my hearing instruments. And okay, I think because of the cable, there is external audio detected. This is also one feature we put specially, in fact. For example, because we are playing the sounds, and since we are playing the sounds, for example, if you connect it to a speaker, that will be really disaster. So we actually detect it if there is any kind of external source. And now, suppose I come back home after my good walk, and I want to go back to the Bluetooth version. All I need to do is just switch on my easyTek device. As you can see, application was smart enough to understand that the Bluetooth device is back, and here you go with the Bluetooth. What do you say? The design for you. So these are some of the features. There are more features over here, like for scanning your transmitters and stuff like that. I cannot show you all the features here, but I would like to invite each and every one of you. We have a booth here, a Avanade booth, and there we are going to demonstrate these things. So if you really want to experience how this whole system works, you can just come over there and we'll show you. So that was all for the presentation. Thanks for listening. And now I would like to take any questions from the audience if there are any. And especially we have a mic over there. So if you want to ask any questions, just let them know, and they will come to you with the mic. So we have one question from there.
The acoustic commands, how does that really work when you don't have, so the Bluetooth, it does also the acoustic commands to the ear, right?
Yeah.
And then you turn off the Bluetooth, and then the acoustic goes straight from your mobile application to the hearing device.
Yeah, that's right.
Okay.
So,
so why do you need what is the reason why the Bluetooth is there if you can control it with your...
Very, very obvious question. I get this question a lot of times, in fact. Yes, that's right. Why do we need this intermediate device? Why can't we just put everything over there? And I believe that is going to happen in the future. But right now, it's the hardware limitation as of now. Because, and why this device exists here is basically for the audio streaming. So if you want to, we wanted to give the audio streaming capabilities to the user. And as of now, in terms of hardware, it was just not possible to put it inside this hearing instrument. And also there can be other business reasons for that I'm not aware of. But that is one of the reasons we need this device. And your second question was how these acoustic commands they work. So they actually they are tones, very high frequency tones, and they encapsulate some kind of commands. So the microphone inside these instruments, they just capture them and they understand and they react accordingly. So I think I'm getting bored over there. We are already short of time. I think I really took too much time, but I'm here. I'll be here, and I'll invite each and every one of you. If you have any questions, just come to our booth, and we'll answer all of your questions and queries. Thank you very much for joining us, and have a nice day. Bye-bye.